Warning! Tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, in this video, we're going to wire up the output transformer, the output tube, and then the driver tube. So first we're going to hook up the output tube and the output transformer, hook the power up to those parts. We're going to get the bias set on the output tube, make sure that the voltages all look good on that part, and then we're going to hook up the driver tube, the RCA jack, and we'll be done. And this is going to go pretty quick. I don't think this is going to take a very long video to do this, or it's not going to be more than one video. So let's get busy and finish this thing up. Okay, so we're going to go over how to wire up the output tube. Here is our high voltage B+ that's coming from the last cap in the power supply that we ran up to the front tag strip. So we're going to connect one side of the output transformer here. We're going to pull the ultralinear tap. Going to put a 1.2K resistor on the end of that wire and connect it to the screen of the output tube. Then we're going to take the plate lead of the output transformer and run it over to the plate pin on the output tube. Here we're connecting pin 8 and pin 1 so that if we want to try using EL34 tubes, we have this suppressor grid connected to the cathode. On a KT120, it's internally connected and that pin isn't used, but just good idea on doing these sort of amps to connect pin 8 and pin 1 together. To that, we're going to hook up the 10 ohm resistor to ground. So then we're going to connect the 1K grid stopper resistor from the grid over to this point on the tag strip. And then we're going to install this 51K resistor between this terminal and where the negative bias comes up to the front tag strip. And we're also going to go ahead and wire up the two test points on the top of the amp, and then we'll be ready to put the KT120 tube in and test to make sure that we've got all of our voltage, that it's conducting, we get the bias set right, and then we'll have the output tube set up. So let me show you what that looks like inside the amplifier. Okay, this terminal tag strip is going to be where we pull our output tube grid to. So we're going to have a 1K grid stopper that goes from here to this pin, which is the grid. Then we're going to have the 51K resistor go from this terminal, which is where our bias supply comes up here to the front of the amp, over to this terminal. Then we're going to bring this wire from the output transformer, and it's going to get attached here, which is where we pulled up our high voltage DC from the final cap up here to this tag strip. And then remember, this is our bleeder resistor. So that connects there. That gets our high voltage DC to the output transformer. Then these two wires come over to the tube. The gray one's the ultralinear tap, and we're going to put a resistor on the end of this wire and attach it to the screen, and then this wire goes to the plate. So that's the screen, that's the plate. And then we're going to connect these two pins together. This is pin 1 and pin 8, and then we're going to run our 10 ohm resistor from here to here, and then this test jack will be connected here, and this test jack connected there. And that's all we got to do to wire up the output tube. So let me get that done, and I'll show you what that looks like. Okay, so we get the red wire from the power transformer, and we hook it up here, which is our high voltage DC that came from back here over this cap. And here are the other two wires out of the primary of the output transformer. Orange one goes to this terminal, which is the plate. You can see we put a resistor on the end of the ultralinear tap wire, 1.2K. It's hooked to the screen. And then from the grid, get a little PTFE tubing on this grid stopper, 1K, that comes over here to this terminal. And then we got our 51K that goes across here. This is where our bias negative supply voltage comes up to this tag strip from this area that we wired up earlier with the bias pot. Then on the cathode, we connected pins 1 and pin 8. Then we put the 10 ohm 0.1% 1 watt resistor for the cathode sense resistor from here to the ground. And remember, this ground wire runs all the way back here to our star ground point. Then we have a ground wire coming from here to the ground test point. And then the positive test point comes up here to the cathode, and it's using this 10 ohm resistor as a shunt. So now we're ready to put the KT120 tube in. We want to turn the bias pot so we have the maximum amount of negative voltage going to the grid. Make sure you twist it in that direction. And we want to put our test jacks on here, power the amp up, and then adjust the bias. And I would start at 100 milliamps and just kind of let everything settle in. And then also, after you get the bias set, good idea to turn the amp on its side, then hook up positive here, ground here, power the amp up, and see how much voltage that you have on the plate of the output tube. And then you can also check how much voltage you have on the screen. Ideally, I like seeing the screen a couple of volts below the plate. So I'm going to do those voltage checks. Then we'll jump back to the schematic and go over how we're going to wire up the driver tube, and then we'll be done with this amp. Okay, the testing done on the output tube turned out great, and I do need to update some of these voltages. They're actually more like 520 to 525 right here, and we've got 500 volts on the plate of this tube. But like I said, I want to get this thing all set up. I want to let them run for about an hour and really get kind of burned in. And then we're going to update the voltages on the schematic before we publish the final version. So we've got everything done to this point right here. We do need to run this 3.6K that's on the tag strip over by the power tube. And then there's a 33 UF cap, and I was able to find a 600 volt one, and I'll show you what that looks like. So all the filter caps now are 600 volts. Gonna run this wire over to the 5-terminal tag strip over by the driver tube. Gonna put a pair of 75K resistors, and I'm not sure exactly why Kegger always uses a pair of plate load resistors, but I'm not going to question it. It's not that big a deal. We're not talking about much money, so we're going to drop a pair of the 75K resistors for our plate load. Comes over to the plate of this tube. Don't let this resistor fool you. I'll explain what this is in a minute. This is the actual plate load resistor. Comes over here to the plate. Here we are triode strapping this 60J7. So we pull up the screen and the suppressor grid with 500 ohm resistors, tie it to the plate, and you can either do it at the tube, at the tag strip, doesn't matter. And I'll figure that out when we get in the amp. Then we have the RCA jack. Positive it comes over to the tag strip. Same thing over here. The negative comes over to the tag strip for the ground. Then we have a 220K grid leak resistor for the driver tube, and then a 2K grid stopper. So it'll go from the pin of the tube over to the tag strip, and then this will jump over to ground. Here we have the LED, and it's a very specific LED. I'll go over that in the BOM, and I'll show you that in the video. And then there's a 220 ohm resistor that goes from this side of the LED to ground. This resistor is the plate-to-plate feedback, sometimes known as the shade feedback resistor. I played with this value. I started out with a 300K and I dropped it down to 150K to help clean up some of the distortion I was seeing. And it goes from the plate of the output tube over to the plate of the driver tube, and it's really a plate to grid resistor. If you look at how this goes, it's a local feedback like this, and we have this 0.33 UF Mundorf coupling cap that blocks the DC but lets the AC signal go through to the grid of this tube, because we got a couple hundred volts positive of DC right here, and we need negative bias on the grid, and that's the purpose of this cap, is to block the DC but let the AC flow through. So let me show you inside the amp what this is going to look like. Okay, so it's time to wire up the driver tube, and this is going to be like the reverse of the other amp, which actually laid out a little nicer, given that with this tube on the other side. So we're going to have to do a little gymnastics here to make this work right. This is our plate. That's the screen, and that's the suppressor. These two are going to have 500 ohm resistors on them tied to this point. And I really would like to make this the plate. So then we just have the coupling cap that goes from here over to here, and that deals with our grid. And then this can be where the power lead comes up to this strip, and then have the 275K resistors go from here to here. And then over here we're going to have the 3.6K dropping resistor from here to here. And then from this point to ground, we have the 33 UF 600 volt filtering cap that goes across there. So then we need to figure out how to get these over here. And what I may do is just get a solid piece of wire, kind of come straight up and then head over and down, and then I can put 500 ohm resistors between this pin, come straight up and tie it onto that solid wire, and do the same here. Have another resistor come straight up and tie into the solid wire, so it can come up, over, and down, and that'll get our plate over here. Now the cathode is going to have to come from here over to this terminal, which means the LED would go from here to there, which isn't going to be a big deal to do. And then the 220 ohm would go from here to ground to finish our cathode circuit. And then we'll have to bring the grid wire over to this terminal here with the grid stopper. So, like I said, there's going to be a little bit of gymnastics getting this to all lay out nice. And then once I get this wired up, and if this is the grid of the input tube, we'll put the grid leak resistor, the 220K, from here to ground. And then with our RCA jack here, the positive will go just a really short wire here to the grid, and then the ground will go to this point here, and that's going to have the amp all wired up. So let me play around with this and kind of figure out the best way of doing this, and I may come back and do like a midpoint video, because if I wait till I have all this stuff soldered, it'll be so cluttered you won't be able to really see what I'm doing. So let me get kind of halfway soldered up, and I'll come back and show you what that looks like, and let's get this thing finished. Okay, here's the start of this, and some of this is going to be kind of in layers, so it's going to be hard to see. So I'm going ahead and showing you as I go along. So we've put in our coupling cap. This is going to be the terminal that's used to gather up all the stuff for the plate of the driver tube, and that connects the plate to the grid. Okay, we have our 3.6K resistor that goes between the high voltage DC terminal and the driver tube supply. We're going to also have a cap that goes from here to here, which I'll add in the next phase. That comes over here on this red wire to this terminal right here. And the next part, we're going to add the plate load resistors, which is a pair of 75K resistors, and then connect this to the plate and these other screen and suppressor grid terminals. So over here we have the grid stopper 2K, comes over here to this terminal. Then we also have the center terminal of the RCA jack hooked up here, as well as the ground for the RCA jack coming over here to our ground. And it's hard to see. Let me see if I can tilt the amp. We have an LED that's connected to this pin on the tube socket and comes over here, and you can see the LED is kind of under this resistor. And then we're going to have a 200 ohm resistor that goes from this terminal to ground to complete the cathode circuit. And then I would go ahead and check to make sure that you've put the LED in the correct orientation. And one of the easiest ways to do this is to get your old multimeter and set it to diode check. And then if you go from this terminal to that terminal, the LED should light up, and you can see it is. And that way you know you've put it in right, because the negative side of the LED needs to go to the ground. So let me go ahead and put on a couple more components and show you what that looks like. Okay, so we have our 600 volt 33 UF filter cap here that's going from the other side of this drop-in resistor, which is the point where the high voltage going to the plate comes from, and it decouples the driver stage from the output stage. That clean power comes over here and goes through these two 75K plate load resistors. And then again, here's the coupling cap from the plate connection over to the grid of the output tube. Here's our plate wire. It comes up, comes over here, goes down to the plate. And then we have our two 500 ohm resistors that go to the screen and the suppressor triode strapping this Pinto driver tube. Again, that's the grid, the cathode LEDs up underneath there that comes to this pin. We got our 220 ohm resistor that comes over here to ground. And then here is our grid leak resistor, a 220K, comes over here to ground. And that's our driver tube. So let me show you a little different angle here so maybe you can see how I did this. And you know, there's probably other ways of doing this, but I just ran these two triode strap resistors vertically and tied it to the plate lead here. So this is the plate on pin 7, and pin 8 and 9 have resistors that come up and tie up here, and it comes across and goes over here to that terminal on the tag strip. So the only thing we have left is the shade feedback, and it's going to connect. Let me zoom out just a little bit. It's going to go from this point, or it could go to this point, it doesn't really matter, and we'll come over here and connect to the plate of the output tube, and there'll be a 150K resistor in that wire. Okay, so the last little bit of the wiring we had to do was fairly important, to hook up the speaker wires. These are the output leads from the output transformer, and the green's positive, the white's the negative, and then this little blue wire here is going from the negative terminal on the speaker outputs over to our star ground point. And the reason for that being so important, if there's ever any kind of a short in the output transformer, we want it to blow the fuse. And by grounding this, that gives a path to ground for any shorted high voltage DC and keeps it from, putting 500 volts on the speaker wires. And so, important little piece there. And then the very last thing was the shade feedback, or the plate-to-plate feedback, and I tied it to this point right here, which was the common point for these screen, suppressor, and the plate wires. And then we run this wire over here. We have a resistor, 150K, soldered into the end of this wire, and then we solder it into the plate terminal. So when you power it up after doing these connections, you want to look at the voltages in the driver circuit, and you're going to see approximately 520 volts right here coming out of the power supply to the front end of the amp. Then after this 3.6K dropping resistor, you should see somewhere around 490 to 495. Then on this point here on the plate, you're going to see somewhere around 230 to 240 volts. And a lot of this just depends on the individual tubes and how much transconductance and all that they have. So you're just looking for a range here. Again, you're looking for, before the plate load resistors, you're going to see around 490. And then here on the plate, you're going to see, average about 235. Then you want to check the cathode at the tube, like after the resistor and the LED, and you're looking for 3.5 to 3.6 volts, something like that, and that's the bias point. And those are the main voltages you want to look for. And then as a final check, come over here and check the plate voltage on the output tube, and with it set to conduct 105 to 110 milliamps, you're going to see about 490 to 495 volts here, and then you should see about 2 volts less on the screen. And everything should be good. And that bias point is going to require, I think I saw between negative 52 and negative 53 volts on the grid of the output tube. So that's it. Looks like a great place to wrap up this video. Well, like I said at the start of the video, I was pretty sure that this was going to get knocked out in one video and get this other monoblock finished. So before I go into testing these things, because we've already tested one of them and I know what this one should do, I'm going to show you the difference between the left and the right monoblocks and some variations that you could do a little differently than what I did if you want to. But anyway, I want to cover that part of this because I did a step-by-step on what would be the left channel, and the right channel, even though it's a mirror of it, there are some things, because it's flipped around, that things are wired up a little differently. I mean, schematically they're obviously the same, but physically, because especially the driver tube stuff, the stuff's reversed and it's on the other side, I'll show you how I wired all that up. And then you'll be able to build a pair of these things like I did. And for listening to start with, I'm probably going to just use my DAC because it's got a volume control, and take any kind of preamp out of the equation because it might color the sound or whatever, which of course the color preamp will, but I don't want to hear what these sound like just hooked up to the DAC. And then I can play around with building the next phase of this project, which is a matching color preamp. And in the next video, I can show you what the chassis look like. And I think they're going to turn out really cool. So, hope you're enjoying this series. I've really enjoyed this. I think these are some of the best things that I've built yet. If you really like this, please subscribe to the channel. Please like the video. Tell your audio friends to come check out my channel. I think they'd probably like it too. Thanks to you Patreon folks. Also, you folks that make donations at the website, super appreciate that. And until the next video, have a nice day.